Here's an oldie, my wave addition program, which is going to simulate the superposition principle. Let's put in a frequency of 1 Hertz, amplitude of 1.5 in arbitrary units, another frequency of 1 Hertz and 1.5, same amplitude. Let's see what these graphs look like. We have the first wave, the second wave, which is identical, and what do you think the sum of these two waves will look like? Well, there you have it. Just add the heights. It's that simple. Now, what if we come down here and we make this have a phase angle of 90 degrees, 1.57 radians? There's the first wave, same as before. The second wave is now shifted over a little bit. Before I go on, try to figure out what the sum of these two waves will look like. You have to add it up point by point. Pause the video and try it first. Okay, here we go. Now, did that make any sense? At the very beginning, green is 0, purple is here, so the sum is right there. And over here, we can see green and purple have the same height. They add up to this. Over here, we have the green at this height. The purple is 0, so the sum is right there. And right here, why is white 0? That's the sum. Because the green is up, the purple is down, equal heights, they cancel out. We've seen this when we were adding up the forces on the bonding curves, and you've certainly seen adding up graphs on math class. So what would happen if we made this 180 degrees out of phase? We have the first wave, the second wave, and what do you think the sum will be? Yeah, it's just straight across. It's 0 amplitude all the way. Now, we could change the frequency. We could have, say, a frequency of 2. And we can have a 0 phase angle. First wave, second wave. Pause the video. Try it yourself first. Whoa, now, doesn't that look complicated? There's no way you're going to memorize these answers, correct? You're going to have to go through here and say, well, it looks like the purple is up, the green is up, so the sum must be up here. When the purple is 0, the green is here, well, then the sum is right at the green. And here we have 0 because up and down are canceling out. And you pick key points as you go along here, and you sketch the graph. It doesn't have to be perfect. Well, we can have a smaller amplitude, say, for example, 0.5, and we can have a much higher frequency. Let's say 10. Let's see what that looks like. That's the first wave. There's the second wave. Now, you're not going to be able to go plot all those points, but you can get the idea of what the answer might look like. Where have you seen something like that before? How about in the ocean? You make some little ripples, and then you have a big swell come by. Well, the ripples reside on the big swell. Well, here's one that you might see on a quiz. I'm going to give you, say, a frequency of 0.5, amplitude 1.5, frequency 1.5, and an amplitude of 1.5. You're going to get a diagram of a wave and a second wave, and you're going to be asked to sketch the sum. You don't have to go through a million points, but pick some key points. Pause the video and try it. Here we go. You only have to look at the top of the purple to see that the green will add to it. And over here, the purple and the green both add up. And right here, the purple is 0, so the sum is just that green. And you can see over here that the green is up and the purple is down, so we have a 0 here. So you can just pick a few key points along the diagram that you get on the quiz, and you'll be able to add up the heights. That's the superposition principle.